This video is a brief overview on level filling control in a US Bottler's filler. To begin with, let us clarify that in US Bottler's current line of liquid fillers, there are fillers that fill to a measured weight in the container by a controlled volume, by a deposited mass, and lastly, to a level within a sealed container. This level control filler will be what we are examining in this presentation. A level filler currently in the field designed and built by US Bottlers will either be a pressure gravity filler, an electronic gravity filler, or a vacuum filler. With the introduction of plastic bottles, vacuum fillers became less of a viable category. So let us focus on traditional pressure gravity and modern electronic gravity styles. All these fillers rely on the same mechanical principle to control final liquid level at the end of the fill cycle. Therefore, the concepts here are valid for both the pressure gravity and electronic gravity machines, though the controls may be slightly different. If we examine a typical pressure gravity lower valve assembly, we can simplify the valve in terms of thinking of it as a human figure, with the head of the valve at the top and the body in the middle. The actuation of the valve takes place by the weight placed on the head pressing through the body when a container is in place. On an ELG filler, there is no discernible head separate from a body, because the actuation comes from an air piston located at the top of the valve stem. But the concept is exactly the same when stroking and closing the valve for the fill cycle to begin and end. There is always a sealer rubber, an inner tube, and an outer tube, and these are the components that impact fill level the most in this area of the filler. A few critical items to remember. Fill heights are never guaranteed for brim filling, especially in hot fill environments. It is very difficult to fill to the top of a bottle and transfer it to a capper without any loss of product, and that is why traditionally a supplier will recommend the machine not be operated in that manner. It is better to fill at least a quarter inch below the top of the finish. Our hot fill height levels established at the end of the fill cycle are the target we design for, as we cannot anticipate changes in fill level due to bottle or aeration issues further down the line. Fortunately, with good clean products provided to the filler settling tank, the expectation is that the process of filling the container at low pressure should not create agitation that leads to fill level control issues. Remember that fill accuracy is not dependent on the position or timing of the valve stroke, and that there is no sensor determining when the fill level is reached. As long as there is enough time to finish the fill, it typically does not matter if the valve stays open longer or starts later when we focus on level control. As it pertains to level control, we will focus on the following. Number 1. Setting the valve fill level target. Number 2. The product pressure control. Number 3. The potential distortion of the container at temperature. Number 4. The liquid shutoff control prior to bottle discharge. Number 5. Bottle handling. And number 6. Product quality in the supply system. Number 1. Setting the valve fill level target. Fill level in the container is primarily set by establishing the distance from the bottom of the sealer rubber to the end of the outer tube. There is also some consistent displacement by the tip, but basically, length of outer tube descent into the bottle is what you control and what you need to remember. All of the valves need to maintain the same spacing, which can be fixed with clamps, spacers, or centering belts between the rubber and the tube body. The reason this sets the level is because at the end of the fill cycle, The outer tube acts as a drain pipe for any product that tries to rise higher in the bottle, and only air remains trapped between the outer tube end to the sealer rubber pad surface sitting on the container finish. Think of it this way. Air rises to the top when liquid enters the bottle. Most of it will escape down the drain pipe near but below the top of the bottle. However, the air above the drain opening cannot flow downward to enter the outer tube, so it is trapped and prevents liquid from rising. And that sets the final fill height. Of course, if the sealer rubber is worn and does not seal, or it lifts due to pressure overriding the weight, it will spray out and overfill. Obviously, in a flexible container, and especially with very hot products, other factors impact that process, so let us discuss one of these: internal product pressure. Number 2, product pressure control. Almost all pressure gravity and electronic gravity fillers use a settling tank that a centrifugal pump feeds from to supply the filler manifolds. Some fillers will use pressure tanks with no pump at all. Both systems are best when they target little to no pressure variations from low flow to high flow states. In essence, we do not want the pressure inside the bottle to vary as the filler runs, or else the forces inside that bottle will vary as well, and can impact the relative volume of the bottle shape. This is especially true in non-round and larger flexible containers. We also do not want higher than needed pressures. The best scenario for this item in controlling fill levels is guaranteeing that fill pressure is low and not a variable during the fill cycle. In some cases, bottle internal pressure can be limited to just the head pressure necessary to fill the manifold, and no more. Maintaining pressure to avoid starving the machine, clearing air from the manifold, and ensuring bottle feed is not interrupted can be a formula for reduced product agitation and prove that you can fill faster with quality than just resorting to turning up the pump pressure. Number 3, bottle distortion. Inevitably though, plastic bottles continue to reduce weight and consequentially are more flexible, so no matter what the pressure, they can expand during the fill cycle. This can impact fill heights if the bottle attempts to return to shape after the valve is removed. Therefore, we recommend a few approaches to address this condition if necessary. The total bottle top load need only be enough to maintain a seal at the disc rubber. Sometimes a physical stop is used to prevent the valve from traveling further down towards the bottle. Or in certain bottle styles, a neck support system can help hold up the bottle. The key is to make sure the center support does not activate a valve from opening when no bottle is present. This is not an issue in an electronic gravity filler due to a sensor controlling the actuator. But most importantly is the understanding of the next topic, flow and pressure control at the end of the fill cycle. Which brings us to number 4, liquid shutoff prior to bottle discharge. The shutoff shoe is often the name for the system that allows us to relieve bottle pressure just prior to removing the filling valve from the bottle to avoid burping and ensuring a consistent fill. The concept is that if we shut off the incoming product flow at the end of the fill cycle long enough, the internal bottle pressure will return to an atmospheric pressure that the overflow connection is tied to. Therefore, we can now remove the fill tube before the discharge star, and the bottle level will not change inconsistently due to bottle expansion. Number 5, bottle handling. There are many clients who have properly established the entire filling control system on the liquid side and then sacrifice that effort in the transfer of the filled bottle to the capping stage. Today, larger discharge stars, monoblocks, and soaped transfer plates make it easier to sweep a hot-filled container into a capper system with minimal slop and product loss. Make sure the timing and attachment plates are synchronized for the best possible bottle handling and timing between valve, star, guide, and bottle shape. Product quality in the supply system. And lastly, a reminder that aerated product fed to the bottle will result in entrapped air bubbles in the final fill. This means that even though the product in the bottle was achieved at discharge, foamy or aerated fills will drop as the air escapes. Typically, there are two major reasons this can occur. The first is that there is air in the product that cannot clear in the settling tank entering inlet to the discharge pump. The U.S. Bottler's pump is specially designed not to create air entrapment, but that assumes clean products are provided. The other reason would be if the filling valve flow was agitating the product and then not given enough time to clear the foam in the fill cycle. To conclude this video, here is a simplified visual representation of the process of level filling. Before a bottle enters the filler, liquid is fed by pump or overhead tank into the upper manifold of the rotary machine to establish a clean supply of product. It will continually flow through the system, bringing the machine to temperature and ensuring a uniform supply of quality product. When a bottle is then positioned in the machine for filling, the valve will penetrate the container, seal on top of the finish, and then stroke fully open. Liquid will begin to flow into the bottle, while at the same time, escaping air inside the container will pass through the overflow leg. When the final fill level is achieved, any additional flow needed to clear foam will pass through the overflow leg and into the return piping under the cabinet. This overflow will eventually enter a settling tank to allow the air to escape to atmosphere, and the liquid will then be returned for reprocessing or recirculation. To guarantee release of pressure inside the now filled container, before the valve unseals at discharge, the shutoff shoe will engage to reduce incoming pressure at the supply line. Then the bottle will discharge, and the process repeats for each rotation. And that should help provide a better understanding of the basics of fill level control in a mechanical valve level filler from U.S. Bottler's Machinery Company. For further insight into our design and operational basics, look for more videos or request a custom video through our website or customer care team.